Hello everyone, myself Babita Padi, lecturer in physics, and today I am going to discuss something very interesting, that is total internal reflection. So students, have you ever wondered that why the diamond sparkles? Have you seen the appearance of water pool on a straight road in hot summer day? Or have you ever heard about the formation of mirage in the desert? Well, you are going to get all the answers to all these questions in this video. So we are going to discuss today about the reflection and refraction of light, critical angle and total internal reflection. So in case of reflection, basically what's happened? Mirror reflects light. Obviously, you can see that when the light falls on a smooth and shiny surface, it reflects light. Basically, the direction of light changes. You can see this is a mirror and an incident ray which is falling on this mirror is bouncing back in the same medium, changing its direction. And this is the normal. And according to the law of reflection, the angle of incidence is equal to the angle of reflection. And the incident ray, the reflected ray and the normal all lie in one plane. So this is all about reflection of light. Then about refraction. What happens in refraction? For refraction phenomena to occur, we need two transparent media. Here you can see glass is one kind of transparent media and here air is one type of transparent media. So while light is coming from a air medium to a glass medium, at the interface it suddenly faces the change in the density, and that's why the velocity of light gets changed, and that's why it deviates from its original path. You can see that if there is no glass present here, the light could have gone in straight line, but due to the presence of the glass medium here, it has little bit bent towards the normal, and this is the normal. And always know that the angle is always measured from the normal. This is the incident angle and this is the refracted angle, you see. And you see this dotted line is some portion of the reflected light, because in case of refraction and reflection, in case of reflection 100% light is not reflected always. Some portion of the light the mirror absorbs. About 98 or 99% light it reflects back to the medium, and about 0.5 or 1% light it absorbs. And same thing in case of refraction also. All the light not get refracted through the medium. Some portion of the light, the dotted line shows that it get reflected. But a very few amount of light that goes reflected, okay? Then I want to ask you a question. A light ray is emerging from glass to air. Which angle is larger, in glass or in the air? Just now we see that in case of refraction, while light is traveling from one medium to another medium, we saw that it has slightly bent from its original path. So now the question arises, if it is going from glass to air medium, which angle is larger? The answer is this angle is larger, the red one, the red marked one. This is the larger angle. So that's why what this indicates, the laws of reflection? It indicates that if a light is traveling from rarer to denser medium, it bends towards the normal. If a light is traveling from rarer to denser medium, it basically bends towards the normal, and vice versa. If a light is it bends away from the normal if it is going from denser to rarer medium. So these are the two important points I want you to remember, because these 2 points are playing a very vital role in understanding the total internal reflection and critical angle. So now let us understand what is critical angle. In case of critical angle, we see a source of light here. Basically it emits a laser, it's like a laser torch emitting a red light beam. It is a very fine collimated beam. In the first case, it has been incident perpendicular to the interface. You see, this is the interface which is separating the water from the air, and the water is having higher refractive index as compared to air. That is, water is having n equal to 1.33 and air is having n is equal to 1. That means light is traveling from denser to rarer medium. And in the first case, it go undeviated. Why? Because there is no component of electric field as it is falling perpendicular to the interface. So it doesn't bend. In the next ray, you see this angle is 20 degree, the incident angle is 20 degree, and the angle of refraction is found to be 27 degrees Celsius, 27 degree. So now you see it has slightly bent away from the normal as it is traveling from denser to rarer medium. In the next trial, we slightly increased the angle to 30 degree, and thereby the angle of refraction becomes 42 degree. And likewise, after successive increasing the angle of incidence, we saw that at certain angle 48.8 degree, the angle of refraction becomes 90 degree. The ray has emerged on the interface which is separating the two medium. That means this is called critical angle, because after that, if we further increase the incident angle, then the light will be reflected. It will not be refracted at all. So you see, the 60 degree is greater than 48.8 degree. That's why here the light is completely reflected back to the medium. And this is how the total internal reflection occurs. So this critical angle plays a very important role. This is the boundary. After, if you cross this angle, if any angle which is greater than critical angle, then the total internal reflection will occur. So then we conclude that when the total internal reflection is going to occur, the phenomenon when a ray of light traveling in a optically denser medium is incident at the surface of a rarer medium in such a way that the angle of incidence is greater than the critical angle, then the light is going to be going back, reflected into the denser medium. That is the phenomenon of total internal reflection. So now, the question I asked you in the beginning, that why we see a water pool on a road during a hot summer day, or why the mirage formation happens in the desert, you got the answer to your question. So let me explain a little bit that what happens basically in the desert. The sand is very hot. It's very high temperature. It is at very high temperature. So when the air which is touching this sand, what happens? The air which is touching the sand becomes lighter and it goes up, forming a rarer medium in the near portion of the sand desert. And like this, you can see, you will see the density is slowly decreasing as the light is coming downward. You can see a layer of air atmosphere here. I have drawn it through the line. This is a layer, kind of layer you can see. That means the most dense air is here. Then it is slowly decreasing, and like such a way that the light will come from denser to rarer medium. Just like we see in case of our total internal reflection, while going from denser to rarer medium, this total internal reflection is happening. So that's why while coming from when the sunlight is falling on the leaves of the tree, and after the reflecting back from the tree, and this ray is traveling through this air, it suffers a fluctuation in the density, just like going from denser to a rarer medium. And it not happened once, but several times. You can see the layer of I have drawn the layer. So when this happens several times, then what happens? At a certain angle, the total internal reflection occurs, which the viewers can see from his eye. So he will see the image of the tree here with green leaves and brown trunk. That means he will think that there is some water near the tree. That's why the reflection of the image formation is happening. but actually it is happening not because of the presence of water, because there is no water there. It is only happening because of the total internal reflection. And same thing with this road also. In the hot summer day, this road is very hot, thereby forming rarer air or warm air here, and the air is cool in this diagram. The air is cool in this region, and this is warm and this is hot air. Thereby, it seems like the image of the sky shown here, and the person in the car thinks that there is water pool in from some distance from the road, and as he approaches the distance, the angle changes. Maybe the angle is less than the critical angle. That's why it suddenly disappears. So that I asked you in the beginning that why the diamond sparkles. It sparkles because once the light enters into the diamond, and as the diamond is having a very low critical angle, so maximum light enter at higher angle than the critical angle, and they get trapped inside the diamond because diamond is a denser medium and they cannot come out from the diamond. They cannot escape from the diamond, and they continue to reflect from all the planes of the diamond because of the cuts we have on the diamond. Different type of cuts, different type of planes are there, and that's why the diamond sparkle. Total internal reflection is also has one more application, that fiber optics or optical fiber is working on the principle of total internal reflection, in which the light is trapped inside the fiber material, transparent glass material, and then the communication, sensing and various application optical fiber serves the role. Okay. And here we learn that the critical angle C, according to the Snell's law, is come out to be sine inverse of 1 by n, where n is the refractive index of the media, and the total internal reflection occurs when a ray of light tries to escape from a denser medium like water or glass to a rarer medium like air at an angle of incidence larger than the critical angle at the interface. So only two conditions the light need to satisfy for total internal reflection to occur. First thing is it should travel from denser to rarer medium, and second one is it should be the angle of incidence should be greater than critical angle. So now we got the answer of all the questions, that why the diamond sparkle and why there is a water pool occurred in the hot summer day in a road. Thank you.